So now we're going to talk about experiments that have outcomes that are not equally likely. So meaning that the probability of everything is not even. And so we look back at the problem that we started with last week, and Jenna and bananas. So we talk about how sometimes you're going to be given this table, and you can just look at the table to find your probability. Now, you're not always going to be given a table with probability, but in this case, if you are given a table, you can just look at the table. So looking at A, it says the probability that Jenna buys exactly 3 bananas. I have the arrow pointing there to show that all we do is look at this part, and the probability is 0.2, meaning 20%. The probability that she does not buy any bananas can be interpreted to mean 0. And so we look here and we have 0.1. There are going to be times when you have to combine multiple events. So what's happening here is we're looking at the outcome, the probability of an event happening. So these are all individual events, or the probability of each event happening. So the probability of picking 0 bananas when she goes to the farmer's market is 0.1. So sometimes we can combine probabilities, such as right here when it says more than 3 bananas. More than 3 means either 4 or 5. You can see that here with the bracket. That's the word. And so we can combine these two because this is 2 separate events and we want to make it one event. And so I can add the 2 probabilities together and I get 0.5. So that's what happens when I can look at a table. Now, remember that there was also this new thing where it was talking about the probability that she does not buy exactly 3 bananas, and there are 2 options. I can either add all the other probabilities, so 0 bananas, 1, 2, 4, and 5, which is what I did here. I got 0.8, or I can take 1, because remember that probability is 0 out of 1, so that 1 is the probability of all of the events, the probability of 0 bananas, 2 bananas, 5 bananas, 3 bananas, all the bananas. But I'm going to subtract the probability of buying 3 bananas because this question is asking how likely is she to buy any bananas or no bananas, but not 3. We don't want to know about her buying 3. This author here has a real issue with buying 3 bananas. So we take 1, which is the probability of all the events, and we subtract the probability of those 3 bananas because we're just taking it out. We're just removing it. Now we're going to look at this problem here because we are given a situation where they didn't give us the probability. We had to fill it in. So we do that by using that formula, the probability of a favorable outcome over a possible outcome. So when we looked at this clock here, we noticed that there are 12 sections because it's a clock, and it's split up into colors. So we first I identified the sample space because I always want to do that just so I know what I'm working with. So red, blue, green, yellow, and then I look at red, and I know that red is just one tiny slice out of the clock, so it's 1/12. So the probability there is 1/12. Here I look at blue, and I get 2/12, but I'm going to simplify always. I'm always going to simplify, and I get 1/6, so I fill that in, and so on and so on. So anytime you are given a blank table like this, all you have to do is look at first your possible, because that's going to be your denominator. Your possible is going to be your denominator. So that 12, the 12 sections is my denominator. And then from there, I start looking at my different options, my different outcomes. And that's going to be my numerator. So green, it was 5 sections or 5 pieces out of the 12. So the probability there is 5